All right, welcome back, everybody, to day two of Foundations of Programming. Yesterday, we weren't able to completely finish off the GitHub lesson. So today, we're going to start off with a small little recap to understand what exactly we did yesterday, how we accomplished it, and then building off on everything that we talked about. So yesterday, we were going through a demonstration of how to create a repository on GitHub, um, and then creating a local repository on our virtual machine and being able to connect the two. You were able to kind of see this in action where you have this tree, your master branch, which has I guess the main timeline or main record of your project, and we were able to create a branch, right, which was essentially just a copy of what the master branch was, but two different versions, so we can create a new feature or make an update and then later on merge it. We didn't really get to see the differences, so we're gonna go ahead and build off from that. Um, so I did not close out my VS Code on purpose. Oh, this is from history clear. Okay. Let me go ahead and make sure my Git is initialized. We talked about the command for initializing a local Git repository on a virtual machine, which was git init. Um, and as you see here, it reinitializes your Git repository. Now, this actually creates a folder on your virtual machine, and you can kind of see uh, where it's telling you that it's creating the folder, but I believe it's a hidden folder. I don't know if I can unhide it from here. If I do reveal and explore somewhere, it creates a folder, and this folder essentially creates snapshots of everything that happens within that time frame of when Git was initialized, and it uses these snapshots to essentially be able to identify the differences between different branches, right? Um, and then with these snapshots, you're able to either go back in time, in a sense, right? In case you maybe corrupted something or something isn't working, or maybe you want to get rid of a commit that you did not intend to have. You use these snapshots to be able to upload them onto your GitHub repository on your browser, right? Upload that to the cloud in a sense. And we talked about a couple commands, but we didn't really explain too much about them, right? And those commands were git add, git commit, and git push. So let's see exactly what those commands were doing. Well, once again, we're going to go to TL draw. It's always better to visualize what is actually happening to understand what's going on. So essentially, what happens is um, you have your project, right? This is your project, or in another word, maybe like your um, your local repo, right? This is what you have created in VS Code, this project here, and you have a README. Granted, this project isn't really nothing. There's no actual code or pages in here besides just the README. But this is what we would consider our project, right? And then on top of that, what we also have on GitHub, we created a remote repository, right? And when I say the word repo, it's honestly just a fancy word for a folder, right? It's a folder of other folders and files. That's honestly all it is. It just keeps track of documentation, your different files, whether they're Python files, JavaScript, HTML. It's able to keep track of all this. Think of like your Google Docs, right? If you guys have Google Doc forms and whatnot, and you have a bunch of them uploaded. If you have a share drive, something very similar to that, right? You're just creating a specific repo or a specific directory that's holding your project, right? And when we first created these, uh, what came first, right? The chicken or the egg. Um, Essentially, it was this egg right here, right? We created this remote repo, and when we created it, we added a README file and nothing else, right? And this existed on GitHub, but we didn't have anything on our computer. Let's move this out for a second. We're going to say our virtual machine, right? This is our computer. These right here did not exist. This was not a thing. There was no connection between these two, right? There was a repo on GitHub, but nothing that was on GitHub existed on our virtual machine. So what we did is we created a directory. We used the command make directory, and we created some kind of test folder, right? That's what I ended up calling mine, I believe. And inside this test folder, we used the command git clone, and then we add this git URL, right? And where does this git URL come from? Well, we got it from, let's see, we got it from the repo that exists on GitHub, right? This is my test repo. We came here, we pressed the big green button, and we got this URL that's supposed to be linking, or it's linked to this repository, right? We got that, and we cloned it to our virtual machine. By doing this, we still didn't have a connection in a sense. All we really did was honestly just download. We downloaded the repo onto our virtual machine, but there's still no connection. This is a one-way connection, right? One way. We got it from the GitHub repository. We brought it to our virtual machine, and that was it. What we then did was we created a Git session using Git init, right? And Git init allowed us to essentially start some form of a snapshot or a record. We started keeping track of what was happening within this this folder here, right? We use git init. It was able to keep track of everything or any changes happening within this test folder directory that had a copy of our repo that was coming from GitHub. And then we added a change. We added a line to our README. Right? What else did we do besides adding that line that I might have skipped over?
Before we added the new line or after?
Before. I skipped over something by accident. What did we do from the time that we
Oh, we
we
changed our branch.
we did
We
change our branch?
we created a new branch and then selected to it using the branch command.
Correct. We
Branch slash b slash whatever, or the name,
did git init,
or dash b.
and then we did git branch, and this allowed us to check our branches. Right? These were the steps that I did yesterday.
Mm-hmm.
Right? This showed me what branches I had. Showed me one branch, and that was main. Right? by default, when I initialize this local Git repository on my computer, it starts with one branch, and that is the main branch. Now, you don't want to make changes on the main branch, right? That's not good practice, right? Ideally, you want to create a new branch that's separate from the main one, so you can work on that copy and then merge it. So what we did was we created a new branch using git checkout -b and then name of branch, right? Uh, let's just say like this. The syntax did not have double quotes, right? And this created a new branch, right? After we created that new branch, we added a new line, right? And that was that. Well, let's check that out. Let's see what branch we're currently on. We do get branch. Notice I am currently within test branch, right? Yesterday, I did a push, right? And we'll see how that comes to play. But notice what my README has right now. As I'm currently within the test branch, this README has this line on line 4 that says I'm currently within my test branch. Now, if I want to switch over to my main branch, very similar to how we created a branch using git checkout, instead of adding the -b, you omit that -b, and instead you just put the name of the branch you want to switch over to. So I want to switch over to my main branch. And we now see here that I switched to branch main. And I get a message here, and I'll explain this message in a bit. But the important part that I wanted to show you here is the README changed, right? That README no longer has that line 4 because the version of the main branch is not up to date, right? The changes that were made in the test branch. So when I switch over to my main branch, it's not tracking these changes, right? There are two different versions. And I see here a message. Your branch is behind origin/main. Well, what's origin? Well, we also have a command called git remote -v, right? And what this does, it allows you to check what repository on GitHub this local repository is linked to. And we see here that the origin from this repository is this link right here, which is the github.com/r/12. That's my GitHub, and the repository called test. This URL seems very familiar. This is the same URL that's right here that we use to clone it from, right? So the origin of this repository is where we downloaded it from, which was my specific GitHub account on this specific repo called test, right? So in a sense, right, it's telling me that my main branch here locally is behind the main branch in origin, right? Well, if you recall yesterday, right before we finished the class, I merged my test branch into main. My main branch now has the changes from test branch. And we see here that on my GitHub repository in the remote version, it does have that change, right? It was updated on GitHub, but after I merged it on GitHub, nothing happened on my computer. It's still behind. Well, that's because we have to manually pull the changes. And we even have something like this right here, git fetch. Right, it's telling me that I can fetch from this repository and I can push to this repository. Well, when I switched over to my main branch, we got this command as well. Your branch is behind origin main by 2 commits and can be fast forwarded, right? Use git pull to update your local branch. If I use git pull, notice what happens. It goes into updating, it fast forwards, and we see here 2 plus plus, right? Those are the 2 commits that's referring to. The plus plus means we added, right? So we added the 2 commits to this branch. 1 file change, 2 insertions. I believe the 2 insertions, even though we only added 1 actual line of text, it's referring to the fact that we added 2 lines, right? It's tracking this empty line on line 3 as an insertion, right? But now my main branch on my computer is updated, right? So even though I merged it on the remote repository, my main branch down here still wasn't updated because it's not like they're just talking automatically. You have to manually update these branches. All right, well, my main branch is updated. Let's go back to my test branch. Hit checkout. I believe it was called test underscore branch. Right, I switched to branch test branch. Your branch is up to date with the origin / test branch on my remote repository. Okay, let's go ahead and walk through again what we did yesterday within those last 5 minutes that seemed a little bit rushed. Now that I'm back within the test branch, just to verify, I'm going to use the command git branch, and it shows me, yep, I am within my test branch. I'm going to add another line. This is my second update. All right, I made some changes to my project. I'm ready to send these bad boys up to GitHub. Well, we did a couple commands, and we're going to elaborate a little bit more on them. Git add, git commit, and git push. Here, this is my second update, or my second, yeah, I think second update. This right here is now something new that my remote repository isn't tracking, right? I want to make sure that I can send that new change up to GitHub, right? Because I made a change here, but if I check my test branch, right? If I go to test branch, my test branch does not have that change, right? I have to manually send these changes up to GitHub. And to do that, we utilize these commands. We are going to say git add and a dot. Well, what is that dot? Well, first and foremost,
Everything.
yes, the dot does stand for everything. But git add, what this does, think of it as, I like using this analogy. Maybe it helps you guys. I hope it does. Think of it as a factory, right? If you had a factory that you're creating goods, you created, let's say this goods creates grills, right? You create grills. This factory is in charge of making grills, right? In this analogy, grills is the changes that are happening on my project, right? I just added a new change, right? This line. In this analogy, that new change is a new grill that I created. Well, how do I get this up to my stores, right? The stores in this analogy is my GitHub remote repository. How can I get this grill up to the store, my remote repository? Well, first and foremost, after my change has been made, I need to put it somewhere where I can stage it, right? To prepare it for packaging in a sense, right? That's called our staging area, right? Because I'm going to be creating multiple changes. My staging area, what that's going to allow me to do is put all the changes that I've been making or all the updates somewhere to get them ready to send out. This staging area doesn't necessarily mean that they're ready to go, but as I'm making updates, I'm just putting them to the side, creating a record that I now have one change, right? If I make another change, like this is my third update, then I would have to move that to the staging area as well, right? That's what get add is doing. Get add is moving all your changes into a staging area to get it ready to package it up and send it out to your remote repository, right? It's essentially creating a log, right? The staging area is just a log of snapshots that you have been making of all the changes within your directory. Now, let's say I'm done. I've created all the grills. I've made all the changes I want to make to my project. I'm ready to ship these out. Well, I have to package it up, right? And that's where the get commit message comes into play. Somewhere I have to package my grills, right? Package up my changes. Let's do this. There we go. I have to package up all my changes and get them ready to load them up and send them out to their stores, or in this analogy, the remote repository, right? That is essentially what is happening here. Get commit is going to grab everything in the staging area and package it up in one simple folder, in a sense, right?
Is that essentially just converting it into a JSON?
In a sense, I'm not quite sure on the actual nitty gritty parts of how it's working, the get commit and how it's sending it. I would have to look into the documentation or how they code it out. We do send information like this in JSON format, so I'm surprised. Oh, who was that? Tim? Was that you that brought it up?
Yeah.
Yeah, that's actually very advanced for you at this stage, uh, which is a good sign from you. Uh,
Do you mind if I ask something real quick?
sure.
When you do git add period, I know you're adding everything, but what if you like added files like by mistake they didn't want to add? Like, how would you undo it?
There is a specific command for that. I don't remember off the top of my head. Let me do a quick research. How to remove a file from a add. There is a command because I've done before. I don't do it often, so I don't remember the exact command. Get restored is what it is. It's get restore and then dash dash stage and then the file name. Right, so you're restoring from the staging area, right? That file. All right, so there is a method for it. I just didn't remember off the top of my head. Or I think I also see other methods that you might use that work the same. Get reset and then the file name. If you want to remove all the files, you can just do get reset. Do not specify a file, and it removes all of them apparently. Same thing with get stage. I'm trying to copy this, but there we go. You can use dot and it unstages all of the files. So you do have commands for it. Which one to use, I'm not quite sure. The situation. I've only had to use it once or twice. Typically, if I'm making a bunch of changes, I've always used get add and the dot because I'm trying to send everything up. Um, but it has happened for me where I'm trying to remove something before. Isn't just not something that I've done commonly where I made a mistake with that. So I'm not too familiar from memory, but I knew there was a command. And this kind of goes back to what I was telling you guys before. Like you guys don't have to know everything from memory. Um, like as long as you're aware that things exist and there's a way of doing it, it's very easy to find that method, right? Um, so yeah, you can use these commands. But back to the analogy, that git commit, it packages up all the items that are currently in my staging area, right? And on top of that, it requires a message, right? It uses the -m flag, and you put whatever message you want to add within the double quotes, right? And that message is what's going to be shown on GitHub to give the person that's supposed to be pulling these pushes and create pull requests to understand what exactly is coming in from whoever sent this up, right? That's what that message is for.
Can those messages include variables?
No, this is just strings. This is just like a sentence, right? So it uses characters. We can talk a little bit more about how we can add more stuff like that as a description on GitHub, because there is a way, and I'll explain that. So once it's packaged up, right, or once you're ready to package up, use git commit -m, and you put a nice little message for your boss, right? Let them know, hey, this is what I got coming up. Also, it's good to put something that's relevant because if you ever have to go back and look at changes in the history of your project, you might want to know when something was done, right? Now, once it's packaged up and it's on the loading truck, and you're ready to send this bad boy out into, the world, into your stores, or in this analogy, our GitHub repository, then that's when we use the git push command. There's different ways that you can use it. I see git push -u origin master. By default, my branch is set to main. So what I do typically is the command of git push origin main. But we'll talk a little bit more specifically about how to do this. But let's actually put it in action, right? I have my change here. I'm going to put it in my staging area, git add dot. And if I check git log, git status, there we go. Okay, git log is for commits. Let me clear this up. I'll split this in a little bit. Git status allows you to check your items in your staging area, right? When using git add, you can see what's in that staging area. And you see here that changes to be committed. And it even gives me that command that we just talked about earlier to unstage, right? So it's even telling you, but it's telling you exactly what was modified. Modify the readme.md. So this is the file that has been added to the staging area, right? Git restore -- staged, and let's do readme.md. Then do git status again. And notice here that it has modified, but in red, right? And it's telling you use git add in the name of the file to update what will be committed, or use git restore to discard changes in working directory. So let's go ahead and do git add again. Put it back in there. Git status. Now it's back in there. All right, so you can add or remove from the staging area. And now let's go ahead and package it up by saying git commit. I'm gonna add a message. My second update. And it gets packaged up, right? It says 1 file change, 2 insertions, 1 deletion. I'm not quite sure what the heck he's talking about on deletion, but sure, we'll check out right now on GitHub to see what happened. Now, if I use git log, now it's showing me the log of my commits. So git status allowed me to see what's in the staging area, and git log lets you see the log of all your commits, right? We have commits and then some weird number here, right? And then it's telling you what you're committing. Well, this weird number here is actually, in a sense, the address to this commit, right? This is the unique identifier that represents this specific commit. So if you've ever had to restore your repository to a different part in time from, like, let's say 10 commits ago, you would have to utilize this ID to restore it. And there's a different command for that, but that's too deep into GitHub, so we're not going to go into it. But just know that you are able to use these commit IDs to do different things, and there's a reason for them being here. It also has some kind of a signature. It tells you the author, the email, and the date that it was done. Right? All right. Now, once it's packaged up and ready to go, I'm gonna go ahead and do git push, and I'm gonna push it up. Now, I didn't have to do git push origin main or anything like that. I didn't have to add an upstream because I already did that yesterday. But if you were to do git push for the first time, it's going to give you a message saying that there's no upstream, right? There's no connection. It doesn't know where to send it up to. It's tracking that we have an origin. We know where we came from, where we downloaded this file. But when it comes to connecting branches, you have to specify where you want to connect it to. All right, but I did that yesterday. If you guys want to recap on that, just check it out on the video. I'm not about to delete this all over again to redo it, so I don't waste any time. But I use git push, and now if we go back to our repository, notice that I now have a new notification here that's telling me that the test branch had a recent pushes 3 seconds ago, and it gives me the option to compare and pull request. Right. So the changes that were made on my computer are now currently sent up to GitHub, but they do not actually exist on GitHub yet. This is almost like a gate, right? It's a way to prevent you messing up your branches or your project. You have to manually approve this change. Right now, if I refresh this page, I am currently within my test branch, right? That test branch does not have I'm currently with the, oh, my bad. It does have the update, but what doesn't have it is the main branch, right? And that's what's important here, right? The main branch does not have it, but the test branch does, right? And that's the main reason for your branches. So you do not accidentally send something up straight to the main branch that's holding your entire project, right? You do not want to break something, and that's why we have the concept of different branches, so we can work on the side on something new before we actually commit to having it on our main project. So let's see how this works. I can click compare and pull request, and it's going to open up this window, right? And it's going to request for me to open a pull request. It's asking me to open something up. Think of it as opening up a ticket, right? Or putting in a request form. You have to put in some form of a request to somebody that you want to merge the test branch into the main branch, right? The first option that it gives you is what branch you're trying to merge in this pull request. Well, by default, because I clicked it on that button on the notification, it's tracking that I'm trying to merge test branch into main. But if you wanted to create something different or merge a different branch, you can choose from here all the branches and what branch you want to merge it into, right? Notice that GitHub automatically tries to check if there's any errors in my code, right? If there's anything in my test branch that will mess up my main branch. This is not foolproof, right? GitHub is not smart enough to know everything that's in the code. So just because it says it's able to merge does not mean that everything is going to be good, right? It doesn't know if the code that you have or the changes you've made are meant to do that, right? What this does is checking for stuff like corrupted files, right? Broken files that are corrupted or missing information that don't work, right? That's honestly what it's checking here. So don't trust the fact that it's telling you that it's able to merge, right? But right here, we're about to put in this ticket, or in a sense, our pull request. You can give your pull request a title. Notice that by default, it's taking the name of my message, but I'm able to add a description here. And here you can add whatever you want right? Updated the README, tracking second updates. And you can also see here that markdowns are supported. You can preview how it's supposed to look like when you actually create this request. You can even put code in here. If I wanted to put a block of code, I would use I would say these backward apostrophes. It's the button where the tilde is at. You put 3 of these, and then you type in the type of code this is supposed to be. For my example, I'm going to use Python, and then you're going to press enter twice. After you press enter twice, you're going to put those 3 parentheses again, those backward ticks. And then the line between the first line and the last line is where your code is going to go. And I can say print hello. Now, if I go to preview, notice here that it creates a code block where I can put some form of code, right? And this is helpful, right? Because what if there was a line of code that was supposed to do something? You can put something like line 43 needs to be changed to a for loop like the example below, right? And then here you can say for I in range of 5, print hello. Right, line 43 needs to be changed to a for loop like the example below, and then you can show the person who who's doing this stuff, what changes to be made, and whatnot. Right. So pull requests allow you to do stuff like this. This is a really bad example, but I just want to show you how you can use code or stuff like that to add things into here. If I wanted to add JavaScript, this I believe has to be Node. It's not JavaScript, it's Node. And then this will be console.log hello. All right. I think if I add Python, but I use JavaScript syntax, it does not look right. See, notice that console is whited out. It does not actually look like some code. But when I switch it out to Node, oh, well, I'm done. Okay. Anyways, some languages it won't work right. It will look weird. But this right here allows you to add certain type of code in here. If you want to add HTML, you can do that. CSS the same way. You can even add bash commands. Like what can we do? Git clone, and then just add some fake URL here, which technically is not fake, but all right, you can add bash commands here as well. But this is just an example, right? Now, if you scroll downwards, it's also going to show you on the left side, it's going to show you the branch that you're trying to merge into, right? By default, we have your main. So I know what's on the left and what's on the right. The left side is the branch I'm trying to merge into, and the right side is the branch I'm merging into it, right? Notice that on the left side, I currently have just one line, which is line 4. And that's why it told me one deletion. Because notice that line 4 and line 5, there's probably an extra space somewhere here or something I'm not seeing. That's tracking it as a deletion, or maybe I deleted it and then added it back somehow. It's very smart. It takes snapshots of everything you do. So at some point, something was deleted here, and then I re-added it. All right, and then it's showing you here on the right side, like what's updated. If you deleted something on the new version, it'll show red over here as well, like something was removed, right? So it tells you the changes and updates from both the original and then what you're trying to merge into it. Right? So it tells you the commits, tells you contributor, it even tells you who it did it, what time, and it gives you the commit details if you wanted it. On the right side over here, you have some options. You can add someone to review it. Right now, I have 0 people because I'm the only person that owns this repository. But if you go to the settings on your repo, you're able to bring other people into your project to help you out with the project, right? And then you can request people specifically to review it, and this will send the person an email notification telling them that they have a new pull request that was created and they were assigned as reviewer, right? You can also do assignees, which I'm not quite sure exactly who the difference between the reviewers or assignees. I haven't really used the assignees too much. I usually just use reviewers, so I'm not quite sure the exact changes between these two. Maybe just other people that are supposed to handle the rest of the pull requests or any changes. You can assign people to this, but you have the options to do stuff like this, where you can identify someone to do this for you, to review your code, right? It's common practice, and you're more than likely whatever company you go to, you're not going to automatically be able to merge something. You're going to have someone above you, right? Some kind of senior engineer who's going to have to review your code, right? Your boss, your team lead, he will be the one that is overall the is going to sign off on whether your code is good or not, right? They will add comment or deny it, and we'll see that in a little bit. But all right, I'm ready to put in this pull request, so I can create pull request. And then this is the actual pull request itself, right? This is the log and record of the pull request. We can see a couple things here. We can see a conversation, the commits in this pull request, files change. I haven't really used the checks at all, but the actual pull request allows you to do a bunch of stuff, right? Here we have a conversation. You can talk in this pull request until things get resolved, right? If your reviewer was coming to this pull request, he will open this up and he will have the option to add a comment. Hey, your code is hot garbage. Fix it all, right? And they can add that comment. Notice that it gets added to the conversation, right? And then you would come back, look at the record of this pull request, and be like, oh, my bad, sir. Let me fix that, right? You go back and you update this until it gets resolved, right? Now you can even add rules here, and we're not going to get too in depth into it, but rules like how many people you require to approve this, right? Restrict creations, restrict updates, uh, require a pull request before merging. There's different rules you can add here to keep people from just automatically merging their code and breaking something, right? If there's a rule here, which you will have later on in your career, you'll have that you need at least 1 reviewer or 2 reviewers to sign off on something. This merge pull request is going to be different. It'll tell you requires approval, right? And then that other person who was assigned here as a reviewer will have to come here and approve your request. And then this would change to this green button that says merge pull request. But once it gets approved, it's good to go. I can click merge pull request. It's going to tell me which email I want to associate this commit to. I'm just going to go ahead and confirm the merge, and then it merges it. And then it gives you the option to delete a branch, right? It's common practice to delete a branch. You want to have a specific branch for just one specific feature. Once you're done, you want to create a new branch. Usually your branches, you have like a standard code of what you call your branches. Like it'll be some kind of abbreviation to the project, to the feature, maybe a date number on there, or a version number, and then your initials, right? There's certain formats that different companies use. Um, and that's why they will delete branches because it's we're working on a different feature or a different version for that feature, so no need for this branch. So it does give you the option to delete it. But if we go back to the code, main, it has that change, right? We now see that main is the same as test branch. And once again, when we come back, if I do git checkout main, notice that once again, I get a notification saying that my main branch on my remote, I'm sorry, I misspoke, on my local repository is behind. It's behind my main from origin. And it's telling me to do a git pull to update your local branch. So now I can do a git pull, and it updates the changes. Do I have any questions on GitHub, whether remote, local, how to create a repository, how to update your branches, creating a branch, navigating through GitHub?
Is there a difference between using the git checkout main and just git switch branch name?
I don't believe so. I typically just git checkout. That's what we teach in the curriculum. Um, you would have to look more into documentation if you want to see the exact differences.
All right, thank you.
So here are some of the git commands that we use. We use git init, which creates a special folder to hold commits. You typically never want to actually mess with this folder because you can honestly just break a lot of stuff. So you never really want to mess around with this. I'm not quite sure where it's at. Let me see if I can find it on my Ubuntu. It's somewhere in my computer, but it does create some kind of folder where it keeps track of everything. I don't remember exactly how to get there, but somewhere on your virtual machine, it creates a folder where it tracks these Git sessions. Git add to add files to the staging area. Git add with a dot to add all new changes / files to the staging area. We talked about git commit. We talked about git status, which shows all files in the staging area. Notice that this is another way of removing something from the staging area. Git rm -cached and the name of the file. So there's different ways of doing it. Git log, and we talked about git push. Now, there is a student practice, right, for push to GitHub. If you go to the curriculum, if you go to lesson 01, you have in this lesson, and let me actually open it up on my VS Code so I can show you. Give me a second. Let me get it up and running. If you have your VS Code with the curriculum open, lesson 01, we have git pair. If you click on the README, you should have something very similar to this. Now, this isn't very readable. If you're new to VS Code, when it comes to READMEs, if you go to the top right, you're going to see what looks almost like a book with a magnifying glass. When you click that, it's going to split the screen that you're currently on and give you a much better formatted version of the README. Make it close up the other ones. And now it's showing you how it should look like if it was actually on GitHub or actually formatted. So these next 15, 20 minutes, we're going to go ahead and go through the Git pair. We have 4 people here today, so we're going to break off into 2 teams of 2. you're going to break up into A and B. As a pair, decide who will be A and who will be B. You're gonna fork the repo that you're currently you're using here to A's account. A will create a text document called story. A will then commit and push up to changes. Okay, let's not do that. Let's do something different. Let's not fork. Let's create something. Let's create a new repository. All right, so instead of forking this repo to your account, I want you to, very similar to the way that we created a repository during yesterday's class, to create a new one. Call it, your Git pair repo, whatever you want to call it, right? You need to create a text document called story. So it should be story.txt, right? Something very similar to that. You can kind of already see it here. Story.txt, a text document. The suffix is the .txt file, right? And then commit and push up the changes. So what should happen is, let's say Tim is A and Jason is B, right? A, which is Tim, is going to create this repo, and he's going to link it to his repository on his computer, right? He's going to clone it, bring it down. He's going to create a new branch, and he's going to add a new txt file called story.txt, right? And once it's created, it shouldn't have anything, but you need to commit and push up the changes, right? So this test branch, or this second branch that you're going to create, that should have a new file that your main branch does not have, right? And you're going to push up the changes, right? Then you're going to add B as a collaborator. That's Jason. So we didn't talk about it, but I'll let you guys figure that out. I'll just show you very quickly what that kind of looks like, right? If you're at a repository, if you go to settings, there's different things that you can do to your repository. And right here, you already see collaborators, right? I need to authenticate, but you can add other people here, I think by email or by the GitHub username. And then you can let people have access to this repository and assist you with it. Afterwards, B will clone the repository to their local machine. They're going to add a line to the txt file and then commit and push the changes. All right, so you should go through all this process. Both of you guys will be making changes, updating them, pushing them, merging them, and so on and so forth. All right, if you guys have any questions, I will be bouncing around between both rooms. Sound good? I see Kenny, sorry, you're still catching up from yesterday. That's fine. Tim and Jason seem to be the most active. I don't know how good Rachel is doing. It's very hard to tell how good she's doing right now, but I'll put you with Tim, and Jason, you'll go with Rachel. And then we will help each other out like that. Let me stop the recording real quick. All right, welcome back, everybody. We're going to continue with today's lesson. We took some time with Git pair. I know we got a little issues coming here and there working with Git, but we're going to finish off Git, and then we can tackle any issues that we may have encountered with our GitHub after class if needed to. We finished the Git pair. Now let's talk about branches a little bit more.
I'm sorry. Can I just make just one thing, and then we can move on.
Of
I'm
course.
on the GitHub repository, and I'm for some reason I can't find how to merge like the test branch with the new branch, at least just to get that process started.
Yeah, you want to create a pull request, right? So on the very top of your GitHub, right? So you go to pull requests.
Okay.
If you don't have the option to compare in pull request, and you put new pull request, and this is from not from the lecture. Give me a second. Let me go to my repositories. the pull request, new pull request, and then you can create something new, right? And then choose what you want to pull into what, right? Um, that's how that's done. Are you not getting the option to do that, Jason?
Oh, that's all I needed. I just need that little push. I think I'm good now to move on. That's all.
All right, right on. Okay, yeah. Thank you for that, Jason. Don't feel intimidated or shy to ask questions and stop me in my tracks. It's just us here, right? I got your. I'm here specifically for you guys to make sure that you guys get everything that you can out of the class. So no dumb question is a dumb question, right? Even if you think it's dumb, it's not, right? I think every question is important. If you don't ask it, someone else is thinking it more than likely. Um, and I'd rather that you guys are getting something out of the class than leaving confused. Um, One thing that I recommend to every single one of you guys, for those of you here and those of you watching the video, because I saw that yesterday's video got 80 views, so I know there's other people watching our lectures. Leave the ego at the door, right? So when you guys, for those of you here, and for those of you going into the immersive program, going to the DevOps evening weekend, whatever program you're going to, leave the ego at the door, right? And what I mean by that is that don't feel like I don't want to seem like the guy that doesn't know what's going on, right? I don't want to look like I'm behind or I'm confused or lost. Who cares, right? Uh, some of us were either painted with the GI Bill, right? You didn't the GI Bill didn't just get handed to you, right? You put in that work for years, so that's your own money, right? So you, in some shape, way, or form, you're paying for this, right? Through your service, right? And you deserve everything that you can out of the program itself. So who cares what everybody else thinks? As I mentioned to you guys yesterday, right? You should think about, this is how I'm going to put food at the table for my family and myself when I leave the service. And that's all that should matter to you guys. So if you have to stop the instructor, stop me, or ask conflict questions, or bug somebody for answers, then that's what you got to do, right? Who cares what's going on? Get what you get. Get yours is what I like to think, right? Get yours. So stop me if you guys have questions. Don't be embarrassed or shy about it. I'll stop and I'll answer it. And if not, Tim already saw it yesterday. I'll spend more time after work ensuring that I can answer the question for you as best as I can. But all right, so moving forward, we talked about branches. A lot of the stuff remaining on the slides were kind of already taught through my instruction portion and throughout just the demonstration. We talked about creating a new branch using the checkout-b method with the name of the branch. We talked about switching to an existing branch already. There is another method where you can merge branches that you have in your Git session on your computer, and you can deliberately call it Git merge, and the name of the branch you're trying to merge. It adds the changes from the other branch to the main branch, right? And here's the biggest thing to note: for the above to work, make sure you are on the branch you want to add to, and in your terminal, right? Run Git merge name of branch. So what that means is, if you want to merge your test branch into main branch, you have to be actively inside of your main branch. And then you're going to call it git merge, and then you call the test branch. So you want to merge the test branch into the current branch that you are on, right? So that's one way of doing it as well, if you want to do it from your Git session. And that honestly concludes any actual instruction for GitHub. And that's all you'll need for the remainder of Foundations of Programming. And that should get you started for when you get into your cohort in understanding the basics of GitHub. You're going to get a class very similar to this. You'll get an even more thorough class once you guys start going through the cohort, or you get to personal projects and group projects. You'll have guest speakers that will come and speak to you, people who are currently working on the industry, to show you how you collaborate as a team, how to plan for a project and work through a project from point A to point B. So you'll get a much thorough example of all this. But we start you off here, dip your toes in the water so you feel a little bit more comfortable. Because once again, to reiterate, the actual cohorts are so much information. It's a fire hose of information. Seeing this early on will help it click faster, so you can worry about all the other more important things while everybody else is kind of confused and trying to catch up, you already took care of all this other stuff. You're not dealing with your GitHub, right? The issue that you experienced yesterday, Tim, or what you're experiencing today, Rachel, you're not going to experience this in the actual immersive program because you took care of it. And that's one of the biggest things that comes with being here with Foundations of Programming. The next thing for GitHub in general is your GitHub profile. So you might have seen it, but you want to build your GitHub profile very similar to the old MySpace days. You guys remember when you had to go in there and put in your music played the moment someone landed on your MySpace profile, and you had all this cool icons and stuff. For those of you that did have MySpace, uh, you want to make it so it describes who you are. When you guys start applying to jobs, and when you're building your resume, you're going to put your GitHub link on your resume. Now, they will check your GitHub a large majority of the time. Now, they're not probably going to check everything in your GitHub, but at least your profile page. Your profile page has a couple things that can tell a lot to the interviewer about yourself, right? This is Guillermo, right? He was the previous instructor for Foundations of Programming. You guys all met him during the pre-work. This is his. I don't know if it's still the same, but this is his version, right? He was able to put something, straightforward about who he is, where he's at. He lives in Austin, Texas, which is kind of funny because so do I, and we've never met. But you put here your skills, right? Your front end, back end, DevOps, stuff like that. Here are some other ones that he found offline of people and their GitHub profile. So there's different ways you can customize this. There's different YouTube tutorials for this or GitHub repos that show you how to do this. There's websites that give you templates as well. So maybe spend an hour on this on your own time whenever you're killing time. Just fix up your GitHub. It's not important right now. Just letting you guys know that personally, you should invest a little bit of time once you guys are coming to the end of your time with Platoon after you're completing your cohort. This is Guillermo's girlfriend's profile. She's also did software dev, and I think you guys saw mine already. Some very basic, straightforward things. You know who you are, what you're currently working on, your stacks, some stats about your languages. This I don't make a bunch of changes because I'm an instructor, so I'm not constantly working on projects. I'm usually just either teaching or doing some updates to curriculum. But you can you know make this look cooler, like you see here. I got the snake video game playing out here for my GitHub. These dots are a huge identifier of how active you are on GitHub, right? So these dots represent what you've been doing on GitHub, whether you're making pushes, whether you're doing code reviews, whether you make commits. These dots will represent that, right? The greener the dot, the more active you were on that day. So when someone looks at your GitHub, it's specifically, honestly, most of the time it's for this. They're trying to see what languages you know, who you are real quickly, and then how active are you? Are you actively working on side projects? Are you working on any project at all? Collaborating with others? Have you worked with other people on other projects? Stuff like that. This says a lot about you as a coder coming in. So definitely spend some time with your GitHub. It'll pay off. Guillermo used to have a story that he believes, he strongly believes that he got one of his, I think his job at Amazon was because of his GitHub profile. He had like a 500-day streak or something on GitHub where he was just working nonstop, and the interviewer was very, very impressed. That was his story. I'm just sharing it here. I don't have that story, but he believes that that was one of the reasons why. So do spend some time on this when you get a chance. The color squares, I just talked about that. These show how active you are on GitHub. And yeah. There are some links for that if you want to look more into it. I believe it should be in lesson 01, the README and the root directory for this one, not the Git pair, but the actual lesson 01 directory. You'll see some links here where to create your GitHub account, but you guys all have that. You can read more about GitHub stuff If you want to learn more about GitHub, you can take a GitHub course here as well. Building out your GitHub profile. We can just click one of these links real quickly to see about it. So just some quick links you can use to help you get started with that. Not too much besides that. Some extra resources on Git and GitHub. So Linux survival, especially if you're struggling with the Linux commands. If you want more on Linux commands, definitely check this out. It's pretty much like a simulator working with Linux commands to get you familiar or comfortable with working with your terminal. So take advantage of that if you have the time. But that's going to conclude today's lesson on GitHub. That stretched out a little bit longer than I would have wanted, but to be fair, today was supposed to be all Git and GitHub. But thanks to the fact that you guys all went to the install fest, it bought us some time. So we're able to spend a little bit more time with this lesson specifically. Do I have any questions on anything that was covered yesterday or today before we move forward to lesson 2?
During the exercise, she was not able to push to my repo. I added her in GitHub as a collaborator, but she still got an error. How would you go about fixing that?
We'll have to look at the settings of your repository. Sorry, give me a second. My dog is being annoying. Yeah, we'll have to look at the settings of the repository a bit.
All right.
We'll probably look at it on the break if you guys are still sitting here and don't walk away to something else. We'll check it out. But besides that, if I have no further questions, let's go ahead and move forward. Next to be how the internet works and HTML. Give me a second. Let me stop sharing because I recently updated this this lesson, but I have not pushed the changes because it's still a work in progress on other lessons. So let me pull that up. So we're gonna start lesson 2, which is how the internet works and HTML. You're gonna see a README that I have not uploaded to the GitHub repo, so you won't have access to it until I add it. I do apologize to it. I've been making changes on my free time. And it's a little slow to make sure that it's very in depth to make sure that we get the best out of it. So I do apologize for that, but we'll still get to go through the updated README here during class. So how the internet works, right? Essentially, the internet enables computers worldwide to exchange data using a standardized set of rules called protocols. Quick disclaimer, I'm not the most tech savvy when it comes to it, so we'll talk about it in easy terms. But what exactly is the internet? Who can give me an explanation in their own words? What do you think the internet is?
The giant network.
Yeah, it's essentially a giant networks of a bunch of computers just talking to each other, right? More commonly known as servers. And the internet, we tend to think it's just in the air, but it's actually just a bunch of cables, right? It's just a cables all across the globe that send data between themselves. It's just a network of cables and computers, right? A bunch of wires. And here we have a small little picture of what it looks like, something very similar to this, and a little map that represents how all these wires are connected. We don't, ever really see them, or you don't hear people talk about them, but this is how it's all working. There's not just some magical particles in the air that's, sending out your JSON file, right? But it's just a bunch of networks and computers somewhere in somebody's attic, right? Here in the States, in in Europe, in China, India, everywhere, all connected. The browser. What is the browser and what does it do? There's a specific word I'm looking for that I've ever used before. What is a browser?
The program that interprets the different protocols and the code into something that can action.
Yeah, essentially, yeah, it is a program. It's more, uh, it's it is a program, but for the normal day-to-day person, it's just it's just a GUI, right? It's just a graphical user interface. That the browser gives you a way to navigate through the internet. It does have different protocols and rules that you can utilize to go to different places using IP addresses and stuff. But in short, it's just a GUI, right, to help you navigate through all this stuff. Makes it appealing to the eye and easy to navigate. All right, we have some key concepts here that we're going to talk about through very briefly. Stuff like the network, right? A group of interconnected computers. That's really what the internet kind of comes down to. It's just a network of computers. You probably heard the word IP addresses, right? And the definition being a unique identifier for a device on the internet. Think of an address to a home. So when it comes to IP addresses, I like to also think of it as like a plot of land, right? Where something lives, right? When you try to reach my website cyberhire.net, I it has its own IP address, and I had to I'm paying for that piece of land, right? That domain to get me to where my website is living at, right? And we have domain names instead of IP address. We use those because imagine trying to memorize the IP address for every single website you're trying to visit. That would be, horrible. So we have, domain names to make it easier, and domain names are essentially just connected to this IP address to make it easier to get to it, right? So essentially, if you're trying to get to my house, instead of you memorizing my address, imagine just having my name connected to that address. And just by saying or typing my name, it will take you to there, right? Um, Packets, a term for small chunks of data. So essentially, when information is sent through the internet, is broken down into smaller pieces of data, which are called packets, and that's what we use to send across the internet, right? It's just data is being disassembled so we can send it out and then reassembled at its destination, right? Its destination. Protocol. This is the set of rules of how devices communicate. We won't get too nitty gritty into this, but it's just how the program, the browser, and the internet works with the applications, so they know how to interact with each other. And then your router is a device that directs packets to their destination. Think of like almost like like someone at the gate, right? Bring you in, letting you know you're bringing in all this data and routing it to its actual point, right? So that router allows it to bring in the data that's being transferred through. Data travel and how it does it. We use data like emails, right? And it's broken down into smaller units, which are stuff like packets. Transmission packets are sent from the source computer to the destination using routers. Routers analyze each packet and determine the fastest path to the destination. These are just some quick terms so you have an idea of what these are if you ever hear them. And the reassembly is the process of bringing back these broken down packets into their original formats. Core internet protocols. Like I said, we won't get too much in the protocols themselves, but some common ones that you'll see. Internet protocol, right? So responsible for addressing and routing the packets. That's your IP addresses. TCP, transmission control protocol. Reliable delivery of packets. I have a typo here. HTTP and HTTPS. You'll see this a lot when you start working with your application. This is reference to the web pages. and the domain name system, which translates human readable domain names into your IP address, right? So going back to, CyberHire being the name for my website, but that specific name is linked to a IP address of where it's located at in the internet. In short, what happens when using your browser, right? When you go to Google and you type in cat memes, right? When you do that, in short, what's happening is that your browser, which is on your client will be your computer, is putting in a request somewhere, wherever these cat memes are located at, right? This request gets sent out, and this request has a different amount of information. It has the type of request it is, right? It has the URL of where the request should be going to. It has, if for whatever reason you need some kind of encryption, it might have some kind of key. It might have a type of what type of data you're trying to receive or send out. Request is, think of it as, if I wanted to request some bananas from Jason. Hey, Jason, I want you to give me a bundle of your bananas. Let me write out this request, right? Think of it as like having a note saying, hey, who am I, right? I want bananas. This is going to go to your address. This is my password, so you know who I am. This is how many I want. Um, and you send out that request, right? This request gets to the server wherever the information you're trying to retrieve or whatnot is located at, right? The server, in this analogy, is Jason. He receives this request and he looks at it and he's like, okay, well, I see who you are. I see what you want. You have the correct password. Everything checks out. Let me grab exactly what you're requesting from me, and then let me send it back to you in a form of what we call a response, right? And then they send it back to the client. And that's pretty much the cycle of how that works without all the extra nitty gritty parts of it. And we can kind of see that a little bit in action. Let me see if I can see it on mine. Let me go ahead and open up the inspect tool. So if you right click on a web page and click inspect, you can see some of the stuff on your browser, like the elements of the website itself. You also have a console. You can see when things are being printed out. Very similar to your terminal. We can even see the network of how things are being done. Let's see if this does it for me. I think I did one for Jason last time. Jason at jason.com. Password is going to be Jason. And we see a couple of things happening. The moment I signed in, something happened, right? Notice that we have two requests here that happened. One request was to somewhere called login, and I got a status here. I can click on the request, and what this request did is sent out the email that was added onto the login form, and I see here jason at jason.com. I even gave him the password, and then the response. Notice here that the response is the email of the user and a token, and we'll get more into this. This isn't the most secure thing, but it was just a quick website for me to keep track of my job applications. So I didn't care too much about it. But notice that the response gave me a token, and this token is what my application is using to keep track of the user that's logged in. Um, and the way that my website is set up is that I use that token for everything else that I do on my profile. So whenever I try to grab something like, for example, the library, we saw another request was made. Let's look at library. If we look at, let's see if I can find it. The token is right here. It was used for that request. the token that was initially given to me on login, I use that so I can grab the library for this user. And you can see that in action under cookies. I have the token. That's what I use to be able to authenticate the user. We can look more into this request right here. Notice it was a get request. I wanted to get information. The information I wanted to get was the library data. I got a status code of 200. Okay, that's just typically a typical common response for when a response was successful or a request was successful. I'm sorry, I misspoke. You can see here the token that was used for this request. And that's kind of how it works, right? We use requests, we put a request to get information, and then we get a response back. And notice that the response I got back from logging in and putting this library request was name was job tracker, applied job was 0, right? So this right here is the tracker, job tracker right here. So I hope this is not confusing you guys too much, but here we just kind of just saw in action. Whenever I clicked log in, I put in a request to my server to get the information that belongs to Jason. And then once that server got the information it needed, it gave me something back, which was the response. This is the raw data of it, which is a job tracker, right? Notice that applied jobs is 0. So there's no applied jobs here, right? Which is why it shows nothing here. Because when I got the response back, my browser got the response back, it saw that there's supposed to be 0 jobs. So it doesn't show anything, right? So when I logged in, it did send a response back to me, and it acted as such. So we can see here in real time how that request and that response works. Once again, in a nutshell, in simple terms, I'm over here, right? Clicking on Google. I'm looking for cat memes, right? I'm typing it into my browser, and it sends that request to my server. As we already saw, that request includes what type of request it is, like a GET request. A GET request is very common when you're trying to grab information. When you're trying to create, and we'll get more in depth into this, the request is a post request. When you want to update something, it's a put request. When you want to delete, it's a delete request. So that request itself has the type of request it's supposed to be. This request will have different parameters, as you saw, like email and password for a login, right? If the website you're using doesn't require login, it might not have that. It might just have like, the what exactly you're asking for it. Like in this example, being cat memes. The server grabs that request, it breaks it open, and checks, okay, let me see what this person wants from me. And then once it receives that information, it looks through its database, grabs it, and then returns it back in the form of a response, which once again we saw right here. This is the response of what it looked like, and then it shows it on my browser, right? Here, what it showed on my browser was the tracker, job tracker, and then apply jobs, but we see none because it is 0. And if I add something here like software engineer at Google and I put save, notice that something else happened here. Another request was made. This was a post request. As I mentioned to you guys before, post request is when you want to create something. I created a new job on my webpage. So it put in a new request, which is post. Notice that the status code I got was 201. And the response is something that it's not something very familiar to you guys, but what I made my thing return was pretty much the ID of what this job is supposed to be. So this is not very too detailed for you. So I apologize for that, but a response was sent back. The way that I had my website handle it was it should send back the ID of the job that I'm trying to get. And with that job, I can populate it here, that job ID. And we'll get more into this when you guys get into the cohort, but notice that it used a request and then it got a response. And that's how it pretty much is working. And it demonstrates it on my browser. right? We have this. If I delete this, a new request is put in. Let's check out the header. This is a delete request. The status code for a delete request typically is 204 with no content. Since you're deleting something, you shouldn't have anything responded back. Notice that no response is being sent back. So the different things that happen here on my application, they all do some form of request, whether it was a post, get, or delete. And that's how that works. So what does a server do? I kind of just explained it. Take a wild guess.
Servers store information, and they provide the functionality of the website that you're on. So they handle GET requests, they handle add, delete, pull, whatever.
Yeah, they essentially store information and they handle requests and send out responses and so on and so forth, right? And what about, is it later on? Oh, it's not. Okay. And when the server gives me this information back, uh, it uses stuff like HTML, CSS, and JavaScript on my browser to display this information, right? And here we see a nice little graphic of how these three different things work on a web page or on your browser. HTML tends to be the skeleton of our website, right? This is what holds the structure of how it should look like. And we can see that here. If I go to elements, this is my HTML document. I can open it up. It's a little bit collapsed. Let me open all these things up. But this is the structure of how my website is broken down. And I can go from top to bottom, right? I'm looking at the root of it all that's holding everything, which is the body. Everything here is the body. Notice as I go down deeper into the nest, here is my profile. I have a button right here, which is the logout button. My single tracker page, my return button, the tracker div. We'll talk more about divs in a bit. The header job tracker. So this is the structure, the framework, the skeleton of my application, right? What do you think the CSS is doing? And it's kind of self-explanatory. The styling, right? It's styling my page. It's what's making it look the way that it looks. Now, I know it's not the most visually appealing website. It didn't have to be visually appealing. I just had it to work, right? I added a little bit of CSS here, but the CSS, we can see here on the right side, this is styling that my web page has. This is what makes it look pretty. It doesn't actually do anything, but it's what represents the visual representation of my web page. So CSS is kind of like the skin of your person, right? The appearance, the style of that person, right? The CSS of Jason is his short bust cut, right? His big ears. I don't know how tall he is, right? However he looks like, his visual representation, the color of his eyes, right? The size of his mouth, nose, everything. That is just who he is, right? The appearance. And then the JavaScript is the functionality, how your website works, right? When you click a button, right? When I clicked log out, that should do something, right? HTML doesn't do that, and the CSS doesn't. The actual part that makes your web page dynamic is the JavaScript. That is what's doing all this extra stuff like logging out, logging in, so on and so forth, sending out these requests, handling the responses, creating new stuff, right? For example, when I'm inside of Jason's profile, and Jason, your password is Jason if you want to use this, or you can just create your own thing. Oh no, okay. But when I add a tracker, let's say it's a to-do list, and I click save, it creates something new here. And let's actually open this up, tracker library. This is an ordered list. I got two lists here. The first list is my job tracker. You can kind of see it when I hover over it. The second list is to-do list. If I add another tracker, take a look at this. Look, when the moment I click add tracker, it made something new here, a form. This is a grocery list. Notice that the moment I click save, it's going to add something new to my HTML. Right? It dynamically added new elements to my HTML. So the way that we handle all this to make our website work dynamically is through the JavaScript. How Jason walks, runs, how he drinks, the way he eats, when he goes and he plays golf with his friends and he swings his golf club, all that is the functionality behind the JavaScript, right? I don't know if you play golf, Jason. But yeah, so that's your HTML, CSS, and the JavaScript. That's how that works. Do I have any questions on this? And the server has all this. The server has all the files that have the HTML, the CSS, and the functionality. It's sending it to my browser. My browser is displaying it. All right, guys, time is 7:42. We're going to take our last break for the night, and then we're going to come back and start working on some HTML today, which should be pretty fun. So let's go ahead and come back at 7:53, since it's now 7:43, and I'll see you guys soon. All right, we're going to go ahead and continue with today's class. So we left off talking about the server, HTML, CSS, and JavaScript. We talked a little bit about the requests and responses and how it kind of all works. Now let's also talk about the actual file structure for our website, right? We have something called the golden rule, which is the separation of concerns, right? Typically, what we do is we have our what we call the main folder here, and you see in the example, and this main folder has three different pages. We have one that's index.html, right, which you can kind of guess already that this is the HTML document. Next is the style.css, which will hold all the CSS for our project. And then we have app.js, which is the JavaScript for our application. Why do you guys think we separate the HTML, CSS, and JavaScript into three different files?
I guess one thing would be to avoid duplication of effort. Like having to type in like the same HTML code over and over again if you have like multiple pages or styles.
Not exactly. Because you will see it. If you guys look through YouTube or you look at other people's applications, if you're looking at tutorials, if you're looking at other people's projects, you might see JavaScript, CSS, HTML all being done within the same document. But that's not very efficient. And when it becomes very inefficient is when you want to ensure that your website has scalability, right? If it's a small application, it might not be too big of an issue, but for a bigger project, that's where it can get a little complicated, right? Um, the bigger the website, the more code you have to do for one, right? So having all three is not ideal because imagine a huge single document with everything all within the same page and trying to scroll through everything until you find what you're looking for. Whether it's working between HTML and JavaScript, trying to figure out how it's going to work, adding styling to your HTML to make it look visually appealing, it's going to make your code look messy, right? So not only will it be messy, but it's going to be horrible to read, and that's not ideal. But the biggest part of it and the biggest reason for it is when it comes time to either update your code, debug it, or just make it bigger in a sense when I'm referring to scalability, right? If you want to increase the size of your website, it can become very problematic because if you want to update something, it's probably going to impact other stuff, right? And that's where you get the biggest issue. Especially if you want to like add updates to styling. Maybe having the styling and the same HTML document is not the best because now you're having to figure out what's styling what and where all this happening. So it's easier to split it up into 3 different files, and there's a way to connect it, and we'll talk about that throughout our class. That way, when it comes to either updating or just working on the CSS, you know everything is all on one page for CSS, HTML is another, and the functionality is on a third. And uh, it's okay to have more than just one JavaScript file, and so on and so forth. Like that's fine. Like you don't have to have it all. Typically, you'll have like one HTML document. When you guys start working with React, you'll have multiple different, I guess, HTML documents that would hold different parts of your code. You might want to make one HTML document that only holds like your homepage, a different HTML document for your gallery, a different HTML document for your sign up, right? You might have a specific JavaScript document that handles the login portion and the sign up portion or getting a library. And then you can import these within a single document to make sure that everything is kind of isolated within its own spot so it's not interfering with itself and it's easier to navigate between all these. Finally, we're going to start getting into some HTML syntax, and this should seem a little bit familiar if you guys have started already on the pre-work. Syntax is a fancy word for grammar, right? So the same way that our English language or any other language you might have has, a way to structure a sentence or how to say something. We have grammar, like, for example, showing possession, right? Like Jason's bananas or Jason's grills. You have the apostrophe s to show possession. Then, Dan, when to use those. How to structure a sentence with an and, right? So like Jason and Tim, right? Whether using a comma or not. When you have multiple things to show, like Jason, comma, Tim, comma, and Rachel, right? So all these are rules that the English language has. Our programming languages have the exact same thing, and we call that syntax, right? So it's a way that things are structured in the language, in rules that we have to adhere to, right? So think of spelling and grammar rules when referring to syntax, and we're going to cover specifically today the HTML syntax, right? Um, when it comes to our HTML syntax, every piece of HTML is wrapped between tags, right? And here we see a prime example of a tag. This specific tag is a paragraph tag, and we have what we call an opening and a closing tag, right? The tag itself is the P, and maybe it'll be better if I show you the README. I think it has much simpler examples from the last time I worked on it. Let me open it up. Here we go. Yeah, we'll use the README instead, right? We use tags. So quick, HTML stands for Hypertext Markup Language, right? That's the abbreviation for it. HTML is the abbreviation for that. We'll talk more about CSS and JavaScript. CSS is the abbreviation for Cascading Style Sheets. And then you guys are already tracking JavaScript, which is the functionality. HTML is the building blocks for our web page. It's what holds the structure. Here is where we define the paragraphs, like the headers, what an image should be like, a form, the links, and so on and so forth. Key concepts that you need to know are going to be these four, which is going to be elements. These are your tags, right? Tags themselves. Uh, these are specific keywords that define specific things, right? So we saw one, which is the P tag. That's your paragraph. You see other ones, and we'll show you right now. I'll show you the most commonly seen ones. We have like header, we have div, a specific tag for image. We have some semantic tags, which we'll talk about. The other key concept you need to know about is going to be attributes, right? So additional information about an element. So you might have a paragraph tag that has an attribute of a class, right? And you can name it whatever you want, right? So the name of that class will be defined by you, but you use these attributes like classes to group things together, right? For example, if you had a bunch of paragraph tags that should all have the same type of styling, you might want to give all these paragraph tags the same attribute. For example, if let's say, let's use my website for example, right? Look at these buttons. These buttons have the same styling, right? They're both, kind of circle-ish, squarish buttons. Well, they're square buttons, but with circled corners. The color is the same. The font is the same. The font is the same color. They have the same background. If I hover over this, notice it. Here's the button specifically, and it has a class, right? Delete tracker button. This one, if we look at the other button, add tracker button. Let's look at the logout button. As a logout button. Um, this might not be the same example. These all might have the same styling, but if they were just going to be very generic buttons, then I would just add like my purple button class, right? So they all share the same type of styling. And this is how you would define that attribute, right? This class right here is an attribute, and there's other type of attributes which we will talk about. And then the next thing is going to be the hierarchy, right? So HTML follows a nested structure to organize the content, and you can kind of already see that looking at this document. The way that we identify what's within what is very similar to your folder structure, right? That you have in VS Code. You have like a bunch of directories within a directory, and each one of these directories have other directories within them that might have files or even more directories. Very similar to that, right? We have the body here that holds all these things. This div that holds everything from here to here. We have another div, right? And it's all nested within each other. So the hierarchy of HTML, it uses that indentation of nested elements. Here's the basic structure of an HTML document, right? This is what a basic website is going to look like. And as we go through this README, I'm going to go ahead and start kind of coding along and showing you in real time what this looks like. And to do that, we have to do a little bit of setup. And I believe I added a setup at the very end, unfortunately. I think it's over here. Okay. Yeah, before we continue with the lesson, I want you guys to do some setup so you guys can kind of follow along if you wish. I need you guys to install some extensions, and I do not see it, unfortunately. Where did I leave? Where do I have it at? I know I added it in this document. Okay, here we go. Setting up an HTML document. I should probably switch the order of this. I need you guys to do a little bit of installing. On your VS Code, on the left side, you're going to see a toolbar. On this toolbar, you should see almost like some Tetris blocks. And if you hover over it, it's going to say extensions. This is the extensions marketplace, and marketplace is a little bit of a misleading word because a lot of the stuff is all free. I've yet to encounter anything that's paid, but I need you to install a couple things. The very first one and the most important one is going to be Live Server. Right, Live Server is going to allow you to open up a development server of your HTML document so you can see in real time any changes that we make, right? It's also going to automatically refresh the browser when we're making changes to our HTML document, our CSS, or JavaScript. So you go into the extensions and type in Live Server. And it should be one of the very first one that appears with the most downloads. It should look like this. Live Server, I already have installed, so I don't get the install option. There's a couple of the live servers. Make sure it looks like this icon right here, this purple like signal icon. Not live server 5 server. just live server. Get that installed. The next one, which is going to be very helpful, is going to be called Prettier, right? And it should look like this, Prettier-code formatter. There's a couple other Prettiers, but the one you want is this one right here. It has 52.7 million downloads, right? So you want to install Prettier as one of your extensions. This is a code formatter, right? It's going to help you format the indentations of your code, and it's going to make it easier as you code along from now until whenever you're done with the cohort or even afterwards. It's a great extension to have on VS Code when you're working on code. Automatically formats code upon save based on defined rules. So spacing indentation. So you're able to fix the settings for this extension if you want to change indentation stuff. But it has a default, which is great. I haven't had to fix this at all. But Prettier is going to allow you to automatically code easier. Polka is another good one. This helps with your JavaScript. It shows the output or runtime values of variable directly inside your editor. So it's helpful for debugging. So that's another good one that you might want to get. Polka, I use Polka.js. That's the one that I have. The one with 3.6 million downloads. It looks like this orange Tetris block. I know there's a couple other ones, but this is the one that you want right here. Next, you want to have Rainbow CSV, and this you won't see the use of it until we get later into the course. But it looks just like this. It's called Rainbow CSV with the word CSV as the icon with the rainbow pattern. This is the one that you want to install. This is going to help you with CSV files. It's a little out of context to talk about it, but you'll know once we get to CSV of why this is helpful. And the next one is going to be VS Code icons. VS Code icons is going to add icons to your files, right? So you don't have to keep looking at the suffix of a file to know what type of file it is. These VS Code icons will prefix your file name with a little logo, right? And it's going to look something very similar to this. If you look at my directories here, notice that the HTML document has the HTML icon to it. The CSS ones have something very similar to that. It just makes it easier to visually see what files you're working with. So VS Code icons is another good one. I'll give you guys about 15 more seconds to get these installed. I'm assuming you guys were installing as I was going through them. But the biggest one that you need for sure right now is live server. Live server is what we need to actually get today's lesson rocking and rolling. Let me keep this here a little bit longer. Either take a screenshot or something, because I know this is not on the GitHub repo yet. I'll give you guys 10 more seconds to take the screenshot if you're not finished. All right, let's go ahead and move forward. So we're going to use live server to get this working. So what I need you guys to do in your lesson 2, either inside of intro to HTML or right outside of it, it does not really matter. I need you guys to create a new HTML document. So let me go ahead and go into lesson 2. I'm going to go into intro to HTML. And I'm going to make a new document. I'm going to call this HTML underscore example dot HTML. This is my example for the class. Right, that makes a new document. I can open it up right here. Now let's look at it. Well, I showed you guys what a basic HTML document looks like, and you might be tempted to code this out individually, but there's an easier way of doing this. But before we do that, let's talk a little bit about this. we see a couple things here, and this is honestly the basic skeleton structure or template that every HTML document needs to have. The very first thing is the doc type at the very top, right? Exactly the way it is, right? This declares the type of document that this is going to be. There's different versions of HTML, and I believe you can actually specify like HTML3, HTML4, HTML5. Just put HTML though. That should default to the latest one. But here, this is where you're specifying to this document what version of whatever code you're using is going to be within here, right? In this exact same format. Notice that all these elements have the less than and greater than arrows to the left and to the right. Some of these have some forward slashes, and we'll talk about those in a little bit of what they are and why they are the same way. But everything starts with the doc type HTML at the very top. Afterwards, we have HTML element, right? Notice that there are two HTML tags here, and it's because one is the opening tag and one is the closing tag. Well, we were kind of talking a little bit about that, but I got derailed. But this is kind of what I was referring to, right? The way that tags work is that they have the opening and the closing tag. And that's where it specifies to the document where your tag starts and ends, right? Um, if this p tag didn't have a class, it would look something as similar as this, where you have the opening tag, and look, thanks to the extension that I have, it auto-populated. But this is how it would look like. You have your opening tag, and let me zoom in a little bit. And then you have your closing tag. Everything between the opening and closing tag is the actual content of this tag itself. So if I wanted to start a new paragraph, I would have to open and close a tag with the P in it. And then the content between the opening and closing tags is going to be the content of this tag, right? So if I wanted to have a paragraph say my name is Roger, I would put that between the opening and closing tag, right? The opening tag, all it needs is the less than and greater than arrows to the left and to the right, and then the actual type of tag it is, which in this situation is a p tag. But the closing tag is a little bit different. How do we identify what's an opening tag and what's a closing tag? Well, we do that with the forward slash here, right? This forward slash lets you as a developer and your virtual machine know which one of these tags is the closing tag, right? That's how you differentiate between both of these. And here we see the example once again. We have the opening tag and the closing tag, and then within both these tags, you have the text content, right? We have hello world, right? This is the basic syntax of an HTML tag. Make sense so far? Do I have any questions before I move forward? All right. So we have the doc type and we have the HTML tag open and closed right here. And everything within inside these HTML tags is our actual HTML document, right? So notice that we have the opening tag right here and the closing tag at the very bottom to let us know that, hey, everything within these two tags is all going to be HTML. Now, within this HTML tags, the first tag that needs to come right afterwards is going to be the head tag, right? And the head tag is kind of like the settings, right? This is a root element that configures the settings of what this document is going to have, right? Notice that within this head tag, the basic tag that's in it is the title tag. So we can give it title. We can give it the type of font we want to use. This is where we're going to put what script is going to be assigned to this document, where we were going to put what CSS is going to go into this document. We can even fix the settings for the name that's going to appear on the tab in our browser, right? CyberHire. If we look at the head, we can see in here within the head of my website, I have a specific tag. Where is it at? It is cyber. It's right here. It's a title, right? The title tag is what fixes this, and I can actually even change this, and you'll see how it works. My website. This won't change my website permanently, but notice how it updates on my browser, right? So this is where you fix the settings. You can see here, we haven't talked about it yet, but here's where I'm linking the script file that holds my JavaScript. We also have an icon. This icon is what's being populated here on my tab. We have a meta tag, which sets the viewport of my application. So this is where you essentially configure the settings of your web page, right? And there's more tags that go within the header that we'll talk about later. But your header tag is the next tag that comes in within your HTML document that you need. And then finally, after the header tag, you have your body tag. And this is where you're actually going to put the meat and potatoes of your application, right? So by default, this is the minimum that you need to get your HTML document working. Now, you can hard code this yourself, or what you can do, which I believe it's working because of the extension. I don't know if it's a VS Code thing or it's one of the extensions we added. But if you do Shift and 1, so essentially an exclamation mark, it's going to prompt you with 2 options. You're going to choose the very first option. You can press Tab or you can click on it, and it's going to give you a boilerplate of that exact same format as a default setting. It's going to populate it for you. So you don't have to go through all that typing every single time you make a new HTML document. Once again, I don't know if this is a VS Code thing or if it's one of the extensions I added. I don't remember exactly where this comes from, but hopefully yours should be doing this if you have your VS Code configured with all those extensions at this point. Notice it has the header, we have the title, we have 2 meta tags. This sets the character set for my font, I believe, and this is for the scale of how it populates on my screen. This is the default setting, right? Let me just change this document title to HTML example, right? And you can see how that works. But here is my boilerplate. Now, here is where live server is going to come into play. On this page, I want you to right click the HTML page, and you should have the option where it says open with live server. And what this is going to do, it should, hopefully, because sometimes we have to mess around with the settings, it should open up your browser that you're working with, or any kind of browser that you have by default already set. It's going to open up that document that you're currently working on. Notice that this is an empty screen because I have nothing on the HTML document. But at the very top on the tab, we see it says HTML example, and that's exactly what I set this title tag to be. Right, so we're able to open up a browser representation of this HTML document that we're currently working on. Once again, this is why live server is very helpful. It helps with the development process, so you can see in real time what your elements are looking like and how your web page is gonna be at the end, right? And as you code along through your VS Code, if your live server is working correctly, it should automatically populate any changes that you make on your document. So let's go ahead and kind of set this up so we can see how this works. We talked about the HTML elements. We have the opening tag, right, which is what starts that tag, right? It's just the less than and greater than arrows with the type of tag it's using, right? It indicates the start of an element. After that, we have the content, which is the information displayed on your page, and then the closing tag, which has the /. Right here, we have a quick example of "Hello World." The tag they're using here is H1, which stands for headers. And we're going to talk about some of the most commonly seen tags in a bit. But let's look at that example here. I'm going to come back to that document I created. And within my body tag, right? Within my body tag, I'm going to start adding some content into my page. I'm going to come in here. I'm going to indent once so I can start nesting within here. And I'm going to start an H1 element. And I'm going to put hello world. And it's going to populate on my HTML page on my browser. All right, we see that hello world is now populated. It has a default font and color. We'll talk later about CSS and how to fix that. But everyone, if you've been coding along with me, you should have something like this. Do I have any questions so far about everything I've covered in the last 15 minutes? Does everyone get to this point?
Yes.
Yes.
That's good to hear. There's always at least one
Yep.
person like, oh, my live server is not working, and I have to kind of go fix it. But great. So good stuff. That's good to hear. Well, we now see how that works in real time. Let's continue with the README. We have a couple examples of other tags. The image tag is a tag that we call a self-closing tag, right? You're going to see that this image tag looks a little bit different than the one that I showed you earlier, because this one does not have an opening and closing tag, right? These tags are known as self-closing tags. These are tags that do not require a closing tab, but instead they are written as a single tag ending with a / before the closing angle bracket, right? So not every element is going to be written with an opening tag and a closing tag. There are some exceptions. One of them being the image tag, right? Here we see the tag. It starts with the opening part of it. It has image. It has a couple attributes in here, which we're not going to talk about yet. It's a little out of scope. But it's all written within one simple tag. Oh. And that one simple tag at the very end of it, it has a /, right? This is known as a self-closing tag. So far we have your regular opening and closing tags, and we have a self-closing tag, right? This should have a /, I believe, and I don't have it. Other ones are like the line breaks. This starts a new line. This is a self-closing tag. Any input field, and we'll talk more about this tag in a little bit. That's a self-closing tag as well. Notice it has a couple attributes. There's different attributes you can give tags. You'll learn them as we go. No worries. Here's some of the most commonly used tags, right? The first one that you just saw is the header, right? This is your titles on your page, right? Like your welcome or your hello user type of header, right? What's supposed to catch the attention of your customer, your consumer, your user. These are your headers, right? The big bold title pages, right? There are 6 of them, right? This ranges from H1 up to H6. The biggest one is your H1 element. The higher the number, the smaller the smaller the text will be. Right? So the smaller the number, the bigger the text, the higher the number, the smaller the text. And we can see that in real time. We have an H1 element right here. If I do H3 and say header 3, you see how that's significantly smaller. I'll use my H1 and say that's a header 1. And if I use an H6 and say it's header 6, you'll see the differences between these H1 elements, right? So we have different sizes of headers. Typically, one page will only have one single H1 element, right? That's just common practice. You don't want to have a bunch of H1 elements everywhere because it's going to take the attention off what you're trying to show to the customer. So you don't want to overuse your H1 elements. You typically only want to have one H1, and then you can use the other one sparingly as well as you go through your page. Another commonly used tag is your paragraph tag, right? This is where you add like large amount of text. If I go here within my H1 element, I'm going to go ahead and indent, and I'm going to start a paragraph tag. When I'm writing large pieces of text within my document, I like to put a line between the opening and closing tag, and this is common practice, so you can see where things are starting and ending. And then within this line in the middle, you're going to indent, and you can then start putting your text in there, right? So it neatly formats how it should look like. Hey, this is my paragraph tag example. I can add a large amount of data or of input to convey my message, right? Something pretty straightforward. And that's where you will write paragraphs, right? Notice how I did this, right? Because it's coming right after my H1 element, I want this to be kind of a part of my header. Like this lets it know, hey, this is supposed to be, for example, my first paragraph, right? And this should be part of that. My second paragraph, you can see how I'm kind of nesting these within each other to kind of show the hierarchy of how this works. Hey, this is my second paragraph, right? So the way that you format your elements when you're trying to show the correlation between the tags and what they belong to, that's when you start working with the nesting and fixing that hierarchy between the elements. Now, this isn't completely perfect, right? Because it's all the same line. We can later talk about how we can indent this so it looks a little bit more formatted. But that's how you want to format your elements to demonstrate the hierarchy between them, right? This H6 will be my third paragraph. All right. By looking at this HTML document, I know what paragraph belongs to what H1 or which with which what header, right? This paragraph belongs to header 1, this paragraph belongs to header 3, and this paragraph belongs to header 6, thanks to the way that I indented this and conveyed the hierarchy between the elements. Links, right? That's another common one that you're going to see. For the links, let's add a link here at the very bottom. Link, I believe it's a self-closing tag. And it's anchor. Sorry, I'm a little rusty on my HTML, right? The link is going to use the A, right? And A stands for anchor, right? You're going to use an anchor tag. This is what's going to show the link, right? And then we can add some content in here. This link sends you to Google, right? Notice that it doesn't look fancy, right? And that's because there's nothing within this anchor tag yet. We have to add an attribute, right? It's going to be the first introduction to the attributes in our elements. But this, by adding the anchor tag, I'm letting this know, hey, this is supposed to be a link. Well, how do I set the destination for this anchor tag? Well, that's done by using this attribute called href, right? This href attribute is where I'm going to add the actual link of where it's supposed to go. So within the opening tag, I'm going to add an attribute. Href is equal to, and notice that it kind of already populates me opening and closing tags. I'm going to go ahead and type in google.com and see how it now updates to look like a hyperlink. The content that's actually being displayed here is the text within the anchor tag, but the link itself is being set within the attribute. When I click this, okay, that's cool. Cannot. Why do you not want to work? Is it because I'm not adding the HTTPS? There we go. Okay. Well, it's very picky apparently. There we go. So I added the HTTPS to my my link here, and now it took me to google.com. Right. So links, that's a very common one that you're going to use. So it's good to know because you're obviously going to need stuff like this when you start working with your application. I can put this to say Google. Right. What I can also do is I can wrap another tag with an anchor tag. For example, what if I had a header here, H2, and this header is going to say, take me to Google. Right? This is its own tag in itself. Well, before the header, I'm going to add the opening tag for anchor. And at the end of it, I'm going to add the closing tag for the anchor. And then let's add the attribute for HTTPS google.com. And notice that it made this header into a link itself. I can click it and it takes me to Google. So you're able to wrap other elements with an anchor tag. You can wrap an image with an anchor tag, right? You can pretty much wrap almost anything with anchor tags. All right. The next one's going to be image. The image tag. This is one of your self-closing tags. I think I put a typo here. It should have the forward slash. But the image tag, let's go ahead and get rid of one of these anchor tags. Once again, a self-closing tag. And just like the anchor, it's going to require an attribute to know what image it's supposed to use. But instead of href, it's going to use the src attribute, which I believe stands for source. Right? It's going to use the source attribute, and this is where you're going to give it what it should be using as an image. Right? Another attribute it takes is the alt attribute, which stands for alternate. And the reason why we add an alternate is in the event this image fails to load, we have an alternate description of what should be appearing on my browser. So before I add an image, let me demonstrate the alt attribute. So alt equals Google icon. Right, notice that it shows like a broken image icon here, and then it shows me the text of Google icon. Well, let's look for a Google icon. Let's see. Let me see if I can find a good link. I think I can copy right here. Copy link address. Now, if I come back to my image tag and I add a source attribute, I'm going to go ahead, I'm going to copy and paste that link to that image. And this is a bad link. When you try to do this stuff, sometimes the link you get is a bad one. So you kind of have to experiment a little bit until you find a good image. Or sometimes it's better to just download the image and have it in your file directory to make it work. Let's go to images. Let me see if this link works. No, this link is broken too. Uh, Trying to find a good one. Downloading PNG. If it doesn't work, there's a different way of doing this, which I can show you guys. copy image address. Let's see if this works. There we go. I got something working. Let me close it up. So I was able to successfully grab a URL for an image. Let me drop this in the chat if you guys want to try it out. But I found some image on the internet. I copied the image address, and I was able to get the Google icon. It's going to bring in this icon with its default size. We require CSS to make it manageable and prettier and whatnot, bring it down to a smaller size to fix it. But that's out of scope from today's lesson, so we're not going to get to it. We'll just leave it like this. But that's how I show an image using HTML. Right? It requires that source attribute. You put in the link, and you have that alternate to show you in the event that link is a bad link. Now, another way to do this, which I was going to do, but this worked, was downloading the image and having it in somewhere in your folder, right? And then what you would add here on the source would be the file path for that image, and it will do the same thing. So if you're not using some link somewhere on the internet, you can do that instead, which honestly is the best way of doing it because links break all the time on the internet. It's better if you just download the actual image and have it in there. The next thing we're going to talk about is going to be lists, right? Lists. Let's go ahead and make a new header. I'm going to do it before my Google link and Google image. It's going to be a header 4. And I'm going to say grocery list. After that header 4, I'm going to indent, and I'm going to start a list. And there's 2 types of lists that you have. You have the order list and the unordered list. So you need to specify which one you want to use. The order list will automatically start making bullet points. I'm sorry, the unordered list will make bullet points. The order list will create list items in a numerical order, hence the name of an ordered list, right? Because this is a grocery list, I don't necessarily need an order list because it can be in whatever order. So I will use an unordered list. So I will start this tag with a UL. And notice that it populates a closing tag. So this is a regular tag with an opening and closing tag. And then I'm going to press enter so I can have an area so I can start adding my list items. Right. Notice it's indented, once again, demonstrating the hierarchy of my elements. Now, to actually add list items, you're going to use the li tag to specify that this is one of the list items within this unordered list. And see, when I add the opening closing tags of li, it populates a bullet point here, but there's nothing in here because there's no content within my list tag. And I can say something like meat. And then I can start another list and say eggs. Sorry, another list item and say milk. And then one more, we'll say bread. And as you see here, I have my grocery list header with a list of different grocery list items. Now, my wife has been nagging me all day. She told me that she has a couple things for me to do, and she wrote me an ordered list from start to finish of what she wants me to do. So I'm going to go ahead and create an ordered list. And the first thing she wants me to do is to dress our kid. And then she wants me to take our kid to daycare. Pick up the dry cleaning. And then finally, clean our apartment. So notice that our order list, it doesn't have bullet points. It automatically started numerizing your list types. So you have two different types of lists, and you are able to customize how these numbers look or the bullet points with CSS. But by default, it has its own plain looking format, right? But this is how you create list items. And the last thing we're talking about with the common ones is going to be divs, right? Divs, the best way to describe what a div is, well, for one, it stands for division, I believe, a division. And it's, in a sense, just a box, right? Think of my website. Let's inspect this. And notice when I hover over this box right here, I can see here I have a div called profile. This profile div holds everything that's supposed to be within my profile, right? Within this profile, I have another div. This is my library, right? So what I did with my website is I boxed different elements depending on their category, right? What this allows you to do is create almost like a categorization for different things. A common one, which is going to be one of your assignments, is the BBC website, right? Look at everything within this website. Everything within here is essentially a div. If we look at the elements within this browser, you can see we have div, which is for app. There's a div for other stuff, and it has some weird names for their different divs. But they categorize things depending on what they were, right? If I hover over this this bar on the right side, everything within this item or everything within this section is all within a div, right? Because they categorize and box things depending on what they were for, right? They might have a div, which they do. Look at this. They have a div for the nav bar, right? Everything with a nav bar is all within its own box. And that's what divs allow us to do, is kind of box things together depending on where they belong to keep things organized. Divs are very commonly used, and one of my favorite things to think about when it comes to our elements is everything within your HTML is honestly just a bunch of boxes within boxes. All these boxes have other things or other boxes within them, and you're essentially creating little boxes with different components. This is my box for my login page. This is my box for my articles. This is my box for my footer. This is my box for my nav bar, right? And then you can kind of isolate individual parts of your website within these divs, so you keep things nested and organized, right? So these lists right here, what I might do is I might nest everything within these lists within a div, right? And this div right here, let me expand a little bit so we can see it. It's already indented, right? This is where my div starts, and this is where my div ends. And all these things from my list are all within this one div. And this might be, I'll give it a class of, you know, list example, right? This is my list example div. And this div only has my lists, right? I can put all the other tags above it within a div tag. Well, maybe not do that. Let's put an opening div tag up here. Let's put a closing div tag down here. And let's indent everything within it. And I'm going to give this div a class of header example, right? Now I got two different divs. One div, this one box, holds everything for my headers, and this div holds everything for my lists, right? So div is another common one. It allows you to box all your elements into a specific category where they all share some kind of similarity. Notice that it didn't do anything for my website. It still looks the same. So it's not necessarily for the appearance of your website. It's for categorizing things on your HTML document for, to keep things like items with like items. Make sense? If you had a bunch of, if you had a huge box with different screws of all different types and sizes, you can create different divs or smaller boxes within this box to put them where they share similarity, right? Lets you organize things. So that's your div, right? For grouping content. We talked about attributes. Attributes provide additional information for your elements, right? We saw hrefs. We saw the source. Some of them are class names. We'll talk more about these, and so on and so forth. We talked about setting up the HTML document. I showed you guys the example for that. And I believe the rest of this, I think this right here. Let me continue with the slide real quick just to make sure we're on track. We talked about HTML syntax. All right, now I'm going to show you guys very quickly with the instructor example with the time that I have left. Let's use everything that we talked about with this example. I'm going to go ahead and open up my VS Code. Now I'm going to open up the states.html, and it looks something like this. You guys can code along with it with me. They should be in the repo with you that you guys have. Open with live server. As of right now, it's just straight text. There is no HTML here. Let's go ahead and work with this real quick. There is a walkthrough if you guys want to walk through it with yourself later. I added it to the README document. It'll talk you step by step on how to do this assignment. But let's see. Here we have a bunch of text. There's no HTML in here. So let's go ahead. I'm going to add my boilerplate. So I'm going to use my exclamation mark, press tab, and get this boilerplate going. And then I'm going to move all of this text within my body. And now, with all this text, I'm going to start using different tags to figure out what all this should be. We see this large list or this long sentence right here. What type of tag do you think should go on this text right here? I hope everybody's excited to be here for our HTML demonstration. We'll be creating a list of states. It's this right here. What kind of tag should wrap around this text?
A header.
A header? Okay, we could definitely do a header.
What are you trying to convey? Like importance, or do you want a paragraph?
We could do paragraph. I want to say this is open to anything. We can do whatever we want here, Tim. So if you want to add something else that's not on this document, like more text, we definitely can, right? This doesn't look much of a title. This looks more of an introduction. So I think that we should definitely put this within a paragraph tag. And that also means we don't have a header. So we can also create a header, right? Once again, you're not restricted to anything here. This is whatever you think would make this web page look right? Kind of fix this and make it look like an actual website. We'll call this states example. and it's not populating. I don't know why it wasn't. My live server is being weird. So I had to refresh my page. But notice that this is now separated. It's within its own paragraph tag. And then I added a header here because it was obviously missing one. There was nothing here conveying to me what this website was or what it was trying to do for me. The next piece of text I have here is a bunch of different cities, I think. Yeah, these are cities. These are not states. I probably have to update this. But what should we do here? We have a bunch of cities. What kind of tags do you think these will be? There's
An
no wrong
unordered
answers.
unordered list.
An unordered or ordered list. What do you want to go with? It don't matter. Like I said, there's no right or wrong answer. Whatever you want to go with, whatever you think makes more sense here.
Yeah, unordered. It doesn't seem to be in any kind of particular importance.
Yeah, let's go with unordered. Let's go ahead. I open up an unordered list tag. Now I'm gonna show you guys a trick here. If you guys want to make different changes to multiple lines, if you hold your Alt key and then you click at different points that you want to edit, we can edit the start of all these lines with li opening tags, and then I'm gonna do the same for the ending, but with the closing tags. And there you have it. I put all these cities into their respective li tag. Next, we have here two more lines of text. What do you think this should be? Line 29. Correct, Jason. A paragraph tag. Go ahead and do a p tag right here. I'm going to make a space and then add it in here. The next one seems to also be another p tag. Looks like a paragraph. We could probably put these on the same one.
Sorry, I was kind of messing with the li part as far as like how you copied and
It's
indented all
okay.
at the same time. I couldn't get the buttonology down. I was trying to mess with it.
Yeah, you're good. You're good. I'm just teasing y'all. All right, so this last tag says, so let's talk about the text here. This says, remember that our class will meet Monday to Friday for the next 4 weeks from 5:30 to 9 p.m. Central. I will bookmark our Zoom link within our Slack. Okay, cool. And the last one is, if one of our friends is interested in Copal Zoom, tell them to check out our website. We should probably add the link to the website here, right? So let's go ahead. I want to turn this into a link. How should I add the link here? What do you think makes more sense? Like I said, no right or wrong answers.
An anchor tag around the word website.
Yeah, we could do that. We could put an anchor tag around the word website. Absolutely. So let's go to website here, and I'm gonna add an anchor tag. And then this requires an href. And I'm gonna say HTTPS. I believe it's, let me just go with Platoon. It'll auto populate. Oh, yeah, Platoon.org. Okay. Platoon.org. Is that it? All right, whatever. HTTPS // Platoon.org. And let's see if it works. Click on website, and I misspelled Platoon. What am I doing wrong? Let's get rid of this. Am I dumb? I'm gonna break for it. Platoon. What? Oh, do I have to refresh it? That's annoying. There we go. My Lysar is not working right. I don't know why. But there we go.
Yeah, I have
And
to
that,
refresh mine too for some reason.
yeah, it's being a little weird right now. It's okay. But there we go. We got the website, and it's taking us to the Platoon specific website, right? So cool. Does everyone understand how this works now? You guys have a nice, warm, and fuzzy. We got more assignments. You guys can definitely work on it on your own. We will take tomorrow to work on the lessons. Let me actually, my bad, I didn't mean to stop sharing. Time is 8:57, so we're about to wrap it up here. Let's see. That took care of the HTML example. We're gonna talk about. I think we talked about most of these. We still have to talk about semantic tags, and then we have two exercises that we're going to do tomorrow. We are going to take time to break up and work on these. So don't feel pressure to do these on your own. We're definitely going to do them tomorrow during class. But we don't have too much left over. Do I have any questions on anything that was taught today?
Yeah, I put in chat, are HTML tags, attributes, etc. case sensitive?
I believe so. I'm pretty sure they are. Let me double check. Pretty sure they are. And if they're not, still don't do capital UL. That just looks weird. It's almost like a naming convention. I've never seen anyone do capital UL or capital H1. That just looks really off to me. So don't don't start putting everything in capital letters. Just keep it all lowercase. If it's not case sensitive, that's more of the standard, right? You won't see it any other way. I mean, just look at any other website when you inspect it. Show me a tag that's capitalized or not all in lowercase. So if it's not case sensitive, doesn't mean anything. Just still do it.
Fair enough.
Any other questions, guys? All right, that's going to go ahead and conclude today's class. Let me stop the recording.